third zoom in a lineup. We'll announce the specs at IBC in September, and we think we'll show a lens at NAB next year, and then it's shipping by mid-year. So we're still a little
another lens besides these three.
Yeah, because we're replacing the lightweight zoom, which is a 15.5 to 45. So we'll replace it with a short zoom as a companion to the compact zooms. And really the big difference is that this covers Super 35, this will cover a 24-36 chip. And we think that we're going to see chip size continue to get a little bigger.
Okay, I'm in the middle of what's up? I don't have a yes.
Okay.
Unless it's about right now, we can talk later. Okay, great. Hey, Rich, when we're going to go in there in a couple minutes, and when we do, can you bring the 28 to 80 with you?
Yeah, sure.
So we can just put up another lens. I'll bring in a different camera, so you can just leave a different lens on here, so I have it up there. Sure. So when we go in, if we can just roll the camera in with us, and what we'll do is we'll just swing the motors out of the way, and we'll leave that lens on. How are you powering? I didn't even look. You have a AC. Okay, so I'll unplug and just replug. Perfect.
Same exact size body, but it's a larger
So we're going to go in there in a minute, and when we do, if you can swap lenses and just bring this one in there with you, because I want to be able to compare different lenses.
Okay.
Great, thanks. So everyone, we're going to start our presentation in a minute. If you want to start moving into the theater space.
Who would know about the little toy camera you got here?
Sorry?
Who would know about this thing?
You can talk to one of our salespeople. Everyone's wearing Able shirts. So this gentleman right here can help you out. If you want to give him a hand. Beep. There we go. That was easy. I am powering you down. I'm going to take you away. That would help. I recognize that power supply. Excuse me, Claire. Excuse me, Claire. Thank you. Yes. Thanks. Watch your back. Watch your back. Rebecca, can you just maybe help start directing everyone to come in? Excuse me.
Power through here? Or?
Just whatever. There's a power strip. You know what I realized? I need a table for all these damn lenses. Maybe we should just put it right over here. We got the round table here. What I'm gonna do is I'm gonna move this over here. Well, hang on. I'm gonna move this table over to next to the camera, and then we'll put everything on the table. Watch your back. It shouldn't matter. Donk.
Do you want to do this now or?
Yeah, you can just put it right up there. Okay. So whenever. Okay. So I'm going to do a demo, and I'm doing it right here. That's where I'm putting my talent. So if you guys want to just take a seat, make yourselves comfortable. So if we can just start working everyone in. Can you get Naomi? I think I said it all. I preset it all. Can we? Am I getting a picture? Oh, hang on. Record out as Rec 709. You should. All right. Well, I'm unplugging. I'll go to the monitor out then. Now you're on monitor out. Okay. $31.05? Yes, thank you. That's a little high on that back one. That one's a little high. Bubble-esque. Thank you. Good enough. Whew, well, that's what happens when a rainstorm happens. A little bit empty in the room. So Jeff, I don't see my laptop up here. I mean, I'm just letting you know it's not. I mean, you're getting it, right? Okay. All right, so let's see how we're doing, people. All right, well, just tell them to get their butts in here. Come on in. I mean, you'll be here. You don't have to sit here the whole time if you don't want. If you want to just sit down, otherwise, whatever you want. It'll be probably half an hour. So. Okay, so do you want to go ahead and give me audio, please? Hi, everyone. Thank you for coming on the rainy New York day to our May Expo for New York. This is Lightweight Cine Zooms. Before we get started, I always like to thank people a little. The first ones that I want to thank are you for coming. Excuse me, in this heady rainstorm. It's, braving the elements and all. It's especially right before the holidays. We have others to thank as well. The expo is part of an initiative by AbleCine, which we call the Learning Point. This is we are currently sitting in the Learning Point Theater, and it is not just a room, but it's an entire program of training classes, seminars, workshops, outreach on the web, ways that we have various technology specialists available to help answer questions over the phone, over the web, in person, and then also through various events such as tonight. The expos are really about bringing manufacturers and the community at large, the production community, together, and really doing it in a focused way as opposed to a regular sort of equipment convention that's just lots of different things. We always try to pick a narrowly defined subject so that people can then sort of just focus on one thing at a time and really delve deeply into it. So tonight it is Lightweight Cine Zooms. And in addition to thanking you all for coming and being a part of this, I have a couple of people who laid out some money to help us all. And so the first is Tiffin. Tiffin, who is not even particularly showing product today, but Tiffin sponsors our Learning Point, and they're doing it as an overreaching thing over a large period, and they're being very generous in helping us do this for the community. This is really about trying to serve the community and having ways to reach out to you, and it's a two-way street. Tiffin wants to hear back. We want to hear back the things that you're interested in learning about, and what areas are important to you. These are the things that we need to present to you. This is all for your benefit. So we say thank you to Tiffin for helping us do this. And then more specifically, to say thank you to the 5 manufacturers who are sponsoring us for this evening. This evening's event. We have Angenieux, Arri, Canon, Fujinon, and Zeiss. Really the big heavy hitters of this industry in the world of optics, for us, particularly zoom optics, PL zoom optics. The fact that they're all here, that they have product here for everyone to see, and they have important people attending here tonight so that you all can talk to them, is all really great, and we really appreciate all the help that they are providing for your benefit. So this evening is about you. It's about what you want to know, and hopefully this is a good educational experience. Please let us know what things you want to see. That said, I'm going to blabber on for a bit, because I have a few things I want to sort of just get out there to you of areas in the idea of lightweight cine zooms that I think are important, and the things that you want to know about. And then I'll shut up. But I started off with, I didn't introduce myself, by the way, Mitch Gross, Application Specialist here at Able. I started off with an area that people, it's as basic as can be, but it's something that people always seem to have confusion about. And so even though it might feel rudimentary to some, I want to just get it out of the way because there's so many misconceptions, and that's focal length. Like, when a lens is 30 millimeter to 80 millimeter, what the hell does that mean? And why are we worrying about it? Well, if you look at this, it's a diagram of a still lens, but or on a still camera. But the point where the beams of light cross over is referred to as the nodal point. That when you have an image on a sensor, it's actually upside down, the way that light is refocused. And the point where that the light all crosses over is referred to as the nodal point of a lens, and the image plane, the spot where it focuses your image, which is where you have your sensor, if it's all set up properly, the distance between the nodal point and the image plane is the focal length. That's what it is. So all of this stuff about, this size sensor is going to be this thing. You take the division of the diagonal of it. It's all nonsense. This is just how you define a focal length. Because people say, well, why don't you call what's a normal lens? And if someone says, if they claim, which I don't necessarily agree with, that a normal lens in Super 35 is, say, a 50 millimeter, but in Still's world, it's some other size, then they say, well, why don't they just call that a 50 millimeter? And then we'll always say a 50 millimeter is normal. Well, you can't do that because you're not describing what is that nodal distance. You're not describing something that is a technical measurement of a lens, because a lens has absolutely no idea what's behind it. You could have a tiny little sensor camera and put that same lens on it. You suddenly changing it to being a different lens? No, the lens never changed. It doesn't know what's going on behind it, whatever you so happen to be looking at it with. You're just describing the nodal distance. That is the focal length. And then what a given focal length lens does for you, well, that's an angle of view, and that has to do completely with the sensor. And I'll talk about that. I'll make it brief because we want to get past this and talk about the lenses. But just this thing of what is a normal lens. This is a great diagram that basically a still photographer, fashion photographer, just had a whole pile of lenses for his Hasselblad. And he, at the end of the day of shooting with his model, he was like, I'm just going to do this just for the fun of it. And he went all the way from a 19 millimeter wide angle down on the bottom right up to it was a 300 millimeter or 350 millimeter, and he just walked closer or further away to keep her the same size, and just have her the same size in the frame, to fill up the frame, and just move back and forth. And the point was, what is a normal lens? Well, we obviously can tell what is a wide-angle lens, and we can obviously tell what is a telephoto, but at what point is it a normal lens? There is no such thing as a normal lens. A normal lens is a cultural bias. Do you want to know why? Gunter, would you please be my assistant? Come up here for just a moment. I am going to demonstrate why we choose one lens to be considered a normal lens versus another. Right over here, sir, if you will. There is a reason that we consider a 19 millimeter not to be a normal lens. It's because we don't talk to people like this. This is generally considered rather uncomfortable in our culture. Thank you. If that was the way we all conversed and connected with one another, then normal would be that wide-angle lens, because all it's describing is that relative distance from one another. You could put whatever lens you wanted, and the fact is it's not the lens that's doing it, it's your physical proximity to the other person, and then just what you have to pay attention to. So if I go across the room, it also is not normal if I walked 100 feet away from Gunter and said, "How you doing?" That's not normal either. And I just sort of focused my brain in on just, on his face. So that would look more like this extreme telephoto. So it's kind of somewhere in the middle, but it's because normally, we probably talk to people at around 5 or 6 foot distance, the normal thing. Therefore, that's a normal lens. It has nothing to do with taking the size of your sensor and the diagonal measurement. Bull. It's a cultural bias. That's my little personal, if you take anything away from it, that's one little thing that I did. It's a pet peeve of mine. But the sensor size of your camera will affect what lens is appropriate for the field of view you're trying to capture. So we have this handout. We have them out front. We can, there's plenty of them to take. This is just describing all these different cameras that are, they say there are 35 sensors, but there's a vast variety, and actually this is the older version of it. I have to change my graphic so you have the fresh one, and it's available on our website to download if you lose a copy of it. It's there for you as a reference tool. It's just a good way of comparing as a sort of a quick reference of what is the relative difference between these sensors, and comparing to Super 35 film, which is the yellow box up on the top. It's a good quick reference of how they compare. And then we're all working people here. This is nice theoretical kind of thing, but how do we have a functional tool that says, well, I've got this camera and I get this camera, and I want to get, I'm taking this thing on a Scout, and if I have a 50 millimeter lens on here, what's the same field of view with that one? Well, we have a tool for that. It's available on our website. You can even use your cell phone to do it. Eventually, we'll have an iPhone app or something for it that'll do the same thing. But this is our field of view comparator, and I looked it up. That is an actual word, comparator. You basically say, I'm using one format here, I'm using another format on that column, and it kind of looks the same as that as the poster thing that I just showed you. It shows you how to calculate that difference and what that relative field of view. There's this term that I consider evil because it just confuses everyone, which is, it's actually written right on here. I hate it, but there's no better way to describe, called crop factor. And people think, what is the crop factor of this lens? There's no such thing. Lenses don't crop. They don't know anything. They don't know what's behind it. It's comparing one format to another. That's all you're doing. So I kind of, there's so many, all all over the internet. There's so many ways that people are misconstruing the term crop factor. It's kind of the work of Satan. They get everyone all confused and their head twisted around. Really, what you're doing is you're comparing one format to another, and so then you say, all right, well, what lens compared to what, what the lens will give me this on one format and this on another, and so I can then figure out. Crop factor tells me, how to multiply my focal length to get the right thing on the other camera to get the same field of view. Hopefully that makes sense. I blabber about this endlessly only because I get asked about it from you guys all the time, and I just want to make sure that, again, this is for you, and want to try and get these ideas across. So even more and more blabbering of it is a video that I did a while back that is on our blog called A Lens is a Lens is a Lens, and it tries to go through this and a bunch of other little ideas with these things, just to give you a sense of these things. So if you're still curious after hearing me go on here, then by all means, listen to me blabber even more right there. So anyway, having gotten that across, just want to get into actually what we're really here about, which is the lightweight cine zooms. First off, we're not talking about these guys. We're talking about those guys. These are still format zooms. I mean, you look at it, this is a 24 to 105 from Canon. That's a 30 to 105 also from Canon. Well, what's the difference besides that one costing a bit more? There's a lot of difference between these lenses. And this is not to put down this lens at all, but there's some major differences between them, and I'm not going to spend a lot of time on that because there's a lot of information out there about why there's a difference. And people say, well, are you a lens snob? I kind of am. I mean, in many ways, a camera is a box that you mount a lens to, and the lens is kind of where the magic happens, and where you can really, between the lens and your lighting, that's where you can really control and shape your images. And so I am a lens snob. I think that you want to have the best tool for the job that works for what you want it to be and what you want to do, and you don't want to compromise. Not saying that that's a compromise of quality. I'm saying it's a compromise of sort of a functionality. And if it's not, the right tool is the tool that you've got, and you want to make sure you've got the right tool, if that makes sense. You want to have the appropriate tool for the task at hand. There's tasks that's fantastic for. There's tasks that's not really the best tool for. So usability is a major factor in that, and why we might not really want to be using those inexpensive little still lenses. And when I have these, I want to make sure I put at least one picture of every manufacturer's lens up. So that's why I'm not saying that these are not usable, or just not saying pejorative to one or the other. Everyone here is great. They do great lenses. That's why they're here tonight. But you have different lens mounts that are available. I'm not going to get into all the nitty-gritty with this because, I have a lens class I teach if you guys are interested, and we're happy to discuss these things at length. But I want to give an overview, the idea, the different things you want to be looking at and thinking about for your choices and in consideration of what things are appropriate for you. You want to start thinking about what mounts the lens is available in, which ways you're going to be working, and what kind of cameras you might want to be using. You want to think about axial focus extension. All the lenses that we're looking at today, you adjust them every which way, and the housing of the lens itself stays absolutely static. And so you can have accessories and things mounted to it and rigged out, and you don't have to worry about that. But if you start looking at other types of lenses, then they start changing and expanding upon you, and that can be fine for certain things and not fine for others. The focal length, just really what is the range that's functional for the kind of work you're going to be doing. If you're going to be handheld all the time, maybe you want shorter focal lengths that won't transmit the movement of your handheld work, and other times you just I need a lens that goes from here to there because I need to make sure that I have that kind of coverage, or maybe I need a couple lenses that cover a certain range. Just purely basic functionality, kind of usability things. What aperture? How fast can that lens shoot? How sensitive? How much light will it allow in? The focus barrel. How well marked out is it? And how detailed is it? Again, looking at that previous slide where we had a still lens. Boy, you have a couple of marks, and good luck on knowing where anything is between 5 feet and infinity, because there's no marks and it's this tiny little space, and as opposed to these cine style lenses that have detailed markings of exactly where you are in your focus point, and you can have a very precise control over it. These can be very important for the way you work. Physical parameters: how big is it, how heavy, how long is the lens, so that if I'm going to be handheld, if it's going to be balanced on my shoulder. This is all tonight about lightweight handheld lenses. So all the lenses that we're looking at tonight are relatively petite. Some are a little bit more petite than others, and everything's a trade-off. All these design considerations. So some of the things here are where you look at, they wanted it to not have other issues, or they want to have certain areas that it really excels at, so they had to make a choice of, we'll give you this, but it means that it's going to maybe weigh a little bit more, or it's going to be physically a little bit longer, or maybe we decided to make it shorter, but it might have some other aspect to it. These are the different things, the design considerations that lens designers go through constantly, because it's all about a lot of juggling of numbers. And then the front diameter, which sounds like such a nothing thing, but all the lenses here tonight are 114 millimeter front or a little bit smaller. There's a couple of them here that are a little bit smaller than that. And what's nice about that is that you can put a little clip-on matte box like we have over there on that Alexa. That lens has a clip-on matte box on it. So again, for lightweight handheld use, and 4x5/6 filters will cover that lens and all the lenses here. So we can have these small, compact rigs. We don't have to start going to very large rigs and large setups, which means that we might need to have additional rod support and just very cumbersome rigs. And it becomes very important, especially also we start getting into tight little spaces handheld. I just can't have something that big. It gets in my way. I can't physically operate with it. So these are the kind of just basic design considerations that we go through. Then we start thinking about the actual performance characteristics. And the last page was all stuff that you can look up on the web. It's all listed out. We have it on our website. There's on other websites. It's just what are those specs? What are those numbers? But you don't really have this stuff put out there. So I'm going to spend a little bit of time. I'm going to try and keep it going, but a little bit of time just talking about these different aspects. MTF means resolution, or how well does the lens resolve an image. Roll-off, I'll explain, is just how difference between the center of the image and the corners of the image. Telecentricity is the direction that the light travels. Geometry is how does it actually, you're looking at a three-dimensional world, yet it's projecting it onto a little two-dimensional surface of a camera chip. What does it look like when it does that? Focus breathing, when you adjust the focus, how does it affect the image other than just the image coming in and out of focus? Sometimes it kind of zooms in and out, the image. And flare and veiling are just how, you'll see flare. If you don't know flare and veiling, you'll see in a moment. So quickly, modular transfer function is MTF. It's a way of measuring. This is a chart that shows it and stuff. And I know in some of the presentations tonight, you're going to see a little bit of that from the manufacturers. But this is the numbers that we use in actually how to actually put it on a scale to how we measure how sharp a lens is, how well it resolves an image. And it's measured out in line pairs, how many pairs of little lines you can see per image height of the size of the frame. It's not something that it's only one of the many things that we talk about here. And there's other things that there's contrast and other areas that there's so many different ways that we look at lenses. But it's people, it's like with cameras, like, what's the resolution? How many K is this camera? Well, that's only one thing that you want to pay attention to. There's a lot of other things that are important when you look at a camera and what it does, look at a lens and what it does. So it is important that you can actually get a lens that's decently sharp. And one of the things you have to think about is the center of the frame versus the edges. Every lens is at its absolute, unless it's a really weird lens, every lens is at its absolute best in the center of the image, and then it gets progressively worse as it gets out to the edges. And how bad it gets out as it gets out to the image is something that, depending on the lens design, it might not get that bad at all. Other times it might fall off very quickly, and you have different aspects to it. One of the things we measure right away is actually in how sharp, not sharp really, but how well it resolves an image at the center versus at the edge of the frames. And we're all talking about Super 35 lenses this evening. So we're looking at a certain image size projection, like say a 30, 32 millimeter image circle, whatever, a Super 35 size frame. That's that chart over there on the right-hand side. That's actually an AbelCine design. We sell this if you're interested. We have different sizes available of it. This is our own resolution analysis chart, and actually in the center, you can't tell because of the resolution of this screen, whatever. But as you get down into the center, it's a bunch of circles within circles within circles that kind of line up, and boy, it gets down to a really, really few just very, very fine lines in per millimeter, for relative to image height, and so you can very quickly, you just take your lens. And we have this, by the way. We'll go back outside later, and you can look at different lenses on cameras out in. On our stage, we have one of these resolution charts actually set up on our stage in our showroom there, and it's the easiest thing to focus on. Much better than any other charts ever made, because you take the lens and it's sort of a ring of them, and when how far around can you get before you can't tell where it comes into focus. As I describe it, it's hard to describe, but you see it and you'll instantly oh God, boom, I can totally tell. And then you can tell on the corners how far. So there's the difference between center, the resolution in the center, which is always going to be much better, versus the resolution at the corners, and how much does it drop off as you get to the corners? How acceptable is that? How, compared to the center, is, pretty much every lens is really sharp at the center. What is the difference? I'm not going to tell you what every different thing is. The things you want to analyze, and you decide what works best for you, how much even it makes a difference for you. Ripple rings, and maybe the lens manufacturers here might have a real name for this, because I can't find anywhere that it describes this, so I came up with the term ripple rings. There's something inside lenses, that especially lightweight lenses, to help make them lightweight and small. We have something called an aspherical lens element. And imagine every piece of glass is sort of a curve in one way or another, and that's going to magnify or demagnify the image, the rays of light. Well, you can have lens elements that are not a continuous curve, that are sort of like a hump kind of shape, or an inverse kind of version of that. It's asymmetrical, aspherical. It doesn't describe a big circle that you've taken a slice out of. By doing that, it's sort of a shortcut that you can use to slice out a lot of weight and get a lot of performance out of a lens without having to have some massive lens. And even some massive lenses have them because they can have a greater range and other things they can do. Well, sometimes, depending on the design, again, like everything is sort of juggling a bunch of balls in the air for the lens designers. They have to make a lot of choices. An artifact of aspherical design is that you can have that illustration in blue, which is way overstating it, just to give a sense of it. You can have the center of the image really sharp, and then maybe an outer a ring, like where those little circles are, right around it, maybe that starts to get a little bit softer, and then it gets sharp again outside it, and then it gets a little bit softer, and then it maybe gets sharp again. So, and this can be an incredibly minute difference, but when we're measuring things, on our resolution charts, we can sometimes actually see this little difference where it's like, oh, sharp, soft, sharp, soft, sharp. And it's because you have this non-uniform shape, but by doing that, they're able to make a lens instead of this big, they're able to make it this big and still give you some kind of range out of it. So again, how bad is the effect? It's incredibly minor, actually, but how much salt do you like in your soup? It's, these are things that you look at to make decisions about how something performs for you and what is acceptable to you and what isn't, and which design you might prefer. Now, roll-off, I was referring before to the idea of, a lens is sharp in the center and gets a little softer as you get to the corners. There's other forms of roll-off, and it's basically as you get to the corners of the frame, you lose resolution, you can have brightness. It can actually be really bright in the center and it gets a little bit dimmer as you get towards the corners. And you can also have chromatic aberration, and that's something that people look at for probably the most in the form of roll-off, which is basically like, imagine the rays of light getting split out into a rainbow. It's magnifying red, green, and blue slightly different as they get off to the corners. Well, what happens when you do that? It's not just that you're creating a little rainbow pattern, but you also, if you look at the lower image there, that's like the extreme corner of a frame that just magnified up, and you can see that if you look closely, you can see that it actually like has a little rainbow effect. But the other thing it did is that it's not just like color shifted, the different colors are different sizes, the different parts of the frame are different sizes. So it actually knocked out your resolution as well. It made it all very fuzzy. So if you, like the balusters, the railing at the top of that building there, it's all blurry blob as opposed to seeing the individual parts of it. And that's an effect of chromatic aberration because you're looking at sort of an image that's been spread apart, and so it all kind of mushed out. That's roll-off. Telecentricity is the idea of light coming straight, well, here's your lens, here's your sensor, and hopefully your light goes straight to it, because film never really cared, but digital sensors are different. They're a bunch of little buckets, and as a little bucket, imagine I'm the bucket all the way in the corner of the frame. Well, if I'm way over at the corner, light's coming from the lens, and if it's got a teeny tiny little rear element, then the light's going to have to come at an angle. On film, it didn't matter, just hit a flat surface. But if it's a little bucket and it's coming at an angle, it might not make it in there. It might not reach the sensitive part is way at the bottom. And so it might not quite make it, and it gets a little dark. And so you see an image like this. This is shot on a digital camera. This plant shot here, if it was shot on that same lens on the film camera, totally even exposure all the way to the corners. Didn't make a difference. But on the digital camera, it did make a difference with that particular lens design because it had this itty-bitty little rear element, and the light all came into the lens, and then it spread way out again at extreme angle, and it didn't quite make it to the ends, to the corners, for that particular design. Another factor with these sensors, these little buckets, is that in order to fill up the bucket as best as possible, at the bottom of the bucket, they don't have just all light sensing material. They have little drivers and circuits and stuff, and so the space of material that actually is looking for light is only part of the area. And also they know that sometimes light is coming at a bit angle, so what do? They put what's called a micro lens or a little lenslet at the front. And it's amazing, these itty bitty little, a million of them on these little sensors. But this little lens kind of redirects the light down into the bottom of that little bucket. Well, if you're coming at an extreme angle, it might not be so sharp to kind of bend it around. So on the right-hand side, you can see down on the bottom corner, it's showing you that it's only a tiny portion of the frame. It's off to the extreme end. It might not be that easy to see here, but it's all blurry. It's all mushy off in the corner there because the light was coming at an extreme angle and trying to get in there. And these are aspects of when you don't have telecentricity. Telecentricity means that the light is as much as possible traveling straight. So some of these lens designs, modern lens designs, are more telecentric than others. You can't have a purely telecentric lens because then it's just a tube and you can't make a zoom lens, you can't make it do things. But if the attempt to be a more telecentric design makes the light for digital cameras travel in more of a straight path so that you get a better, cleaner illumination and sharpness throughout the frame. That's what you're looking for in telecentricity. Geometry, this is just how the light is getting bent around. This is not my illustration, so I'm not going to take authorship of the term of mustache, a spherical distortion. But again, not describing a continuous curve. That's the one on the far right. You see that it kind of has like a bit of a lump, so it's like an old style mustache kind of thing. So the barrel is going out, pincushion is squeezing in, and the mustache is sort of a little halfway in between. And again, most of the time, do we even notice it? Well, how bad is it? How much maybe we like the effect a little. Maybe it sort of lends a feeling of depth to the space. Different ways of looking at it, different thoughts. These are just different things you can look at in the lenses to get a feeling for them. Now, flare and veiling, and they are two separate things, and a lot of people get them overlapped and confused. Flare is actual reflections in the shot. So you look down on the bottom of the frame, that little purple circle, that's a flare from the sun. It's just blasting in there, and you're seeing a reflection on the surfaces of glass and the optical coatings of the glass inside the lens. Veiling is sort of that glow or bleed. So if you look at the guy there on the left, his face is kind of filled in. It's a little bit illuminated compared to the person on the right-hand side who's all dark in silhouette, and that fill didn't, light wasn't actually reaching around. It was bouncing around inside the lens and creating sort of a false bit of fill. It's just bleeding over other parts of the frame, and it's reducing your contrast. It has to do with the different coatings and also the physical design of the lens, but it's actually reducing the contrast of the image, and to the point where it actually affects how you might choose to expose your image, and also just how you might choose to frame a shot, because you might not want to have that in your shot, and you might have to start thinking differently about using one lens versus another that may be more or less affected by either flare or veiling or both. Sometimes one is more susceptible to one than the other, and these are just things to look at with a lens. It's easy to test, by the way. You can take these cameras and just point the lens up at the at the lights inside our showroom, and you just like, oh, what's it doing here? What's happening? It's like, okay, and you can start getting a sense of what's happening. Now, lens personality is this thing that, this great ineffable idea. Now, bear with me, I'm almost done. I just want to give you guys the different areas that you start thinking about. So, to give you a little hint of it, that is a photograph of a plate that we used to use for film cameras when we tested like the image stability and things. It's just a sheet of metal with a bunch of holes in it, and it's not curved or whatever, anything. It's a flat piece. I took a lens and knocked it way out of focus and it made that image curve around like that. So I'll tell you about what that is in a second. But there's 3 areas: color, focus fall off, and bokeh. And bokeh, which is this wonderfully misunderstood term. So first one, color. A lens can often just pass through accurate color and just be very pure. And this is sort of a design ethos of different manufacturers and the way they approach their optical design. Do they want to have clarity and accurate color reproduction throughout the spectrum? Or maybe they want to have some warmth. And what is warmth? Well, maybe it's kind of towards the reds, yellows, part of the spectrum. And why would you want to do that? Well, skin tones are most likely, in general, the reason we might want to do that. Because if we put more, if we weigh the color of the light in the direction of skin, which is, let's face it, for the most part, what we shoot people. And so it enriches that part of your image that much more. And it gives you more information. It weighs everything, all the data that's saved in the camera's files and whatever. Everything is going to be weighed in that direction. It's going to be heavily towards giving you the most information in that part of the color spectrum. And so, yes, you can always take a thing and go and do color timing later and tweak it all any which way. But the more you start with in the area that you like, the better off you are, the more control you have. And so it's a lot of people like to have really clean glass and say, I want to control this, and I'll design it my lighting, and I'll design where I want it to be. Other people are like, I want to weigh it in this direction because I kind of like the way that looks, and I'm just going to work with that. So some of these lenses actually are designed to be a little bit on the warm side, and that kind of has a certain feel to it, and people like that. So it's a thing to look at in lens design. Focus fall off is an interesting one, and I put the Zeiss lens up there because Zeiss has a very particular style with their focus fall off. Focus fall off means like, here's your point that's in focus, and then how quickly does the image drop out of focus, right? On either side of that arbitrary little diagram there is the image is focus dropping off. And you can say, well, it's based on a simple formula, but it's not really true. Different lens designs will have different amount of focus fall off. So you'll have some lens designs that are more of a gentle curve, where here's the spot where things are really popped in focus, and then how far behind and how far in front, how quickly do you see it drop away? Zeiss, as an example, really likes to have a pop, a snap to that focus. So when it drops off very quickly. And so in all their lens designs, you really see where it has that moment where it just really is. It just feels really crisp and really sharp. And then it fairly quickly drops away. Now, you can always adjust depth of field on the lens by, stopping down, and you can have a greater range. But when it is in focus, it feels in focus. Other lens designs, people think, they have a certain different attitude towards it, where they kind of like to more gently roll it in and out, and it's a little different look. All of these are extremely subtle differences, but, the subtle difference is, what wins people's Oscars and stuff. So they're all little tools that you can use to the style of what you might like. Now, bokeh, and this is kind of the area that people think of when they think of bokeh. They think of the shape of out-of-focus elements in the shot, and and what an iris does. So here's someone took a lens and just put a little heart in front of the thing, and it made that out of it. I guess if you're doing some wedding videos, maybe it can be useful for you. But that's not really what bokeh is about. Bokeh, it's a term that only existed for, it's less than 20 years. It was a photo magazine, 1997, that came up with the term from Japanese bokeh, which means blur or senility, because it's all fuzzy. How the out-of-focus part of the frame is rendered. As things move out of focus, how are they rendered? That's what it means. And different lens designs can render it in a different way. So here's an image over there that is very coarse bokeh. And what you can see is it sort of has a tunnel sort of effect to it. The edges have this sort of rounded effect. And I'll show you something else in a moment. But that's an example of a very coarse bokeh over there. And it's only partially defined by aperture design. So everyone's always like, how many iris blades? And I bet every manufacturer here is going to tell you how many iris blades they have in their lenses. And that's good to know. But it's not the only way that we think of bokeh. And in fact, if anything, it's probably, in my mind, the least important aspect of bokeh. It's a good measure to know, but it's not the only thing you want to think of. It's how we perceive depth. So I'm going to pop out of my presentation for a moment to show you a video that I did. Now, this is actually I did with some still lenses, because it's just what I had available as a test, but it gets the same idea across. And these are just different lens designs. Now, all of these lenses are 50 millimeters, but they're different designs. This was Zeiss Ultra Prime. This is our lens projector that we use in back, and I just took the image and I just knocked it in and out of focus. In fact, you'll see my hand come in at the bottom of the frame. And as we go in and out of focus, you can see that the image kind of changes size a little bit, but the shape of everything pretty much stays the same. That's just sort of the Zeiss design and the look of their lens. Now, Cooke S4, people talk about how the shape and the geometry of the lens and stuff. So I took that one. Again, these are all wide open on their aperture, around the same aperture, and I knocked them in and out of focus. And you see how it gives a kind of like a tunnel kind of effect? It kind of looks like the center, depending on your perspective, is either coming at you or going away from you. It magnifies the center a little bit differently than it does the edge of the frame. And then I took an old Cooke lens that really went extreme. And by the way, if you look at the brightness fall off in this particular old lens. That's really one that drops off quickly. But people really love the look of this lens. If I take this one, which is, 60-year-old lens design, and knock this one in and out of focus, and you can really see, if we get to the moment where I knock it out of focus, you see that sort of cone effect? You see how it kind of like stuck out at you? Well, that is lending a sort of an artificial feeling of three-dimensionality to your two-dimensional image. So that's a quick idea of what bokeh can look like. And to me, that is actually a much more important aspect of bokeh than you ever really have to think about with just simply, how many iris blades does the thing have, because I care more about how it affects my image all the time. I have some demonstration stuff to do, but real quickly, I'm going to just give a quick shameless plug to Abel Cine and some of our optical devices. We have a PL/2 optical extender, a doubler. This optical doubler will go on the back of every lens that we have here today, except the Optimo DPs from Angenieux. Those particular lenses have a super deep rear lens mount that nothing can fit behind. But every other lens we cover. In fact, our optical doubler covers more lenses than anything else in the world. It's even like certain prime lenses that like ultra prime 100 millimeter, which is crazy deep in the way it's designed. Ours can cover, and it's designed highly telecentric. It's really designed to be the best optical performance in the world. A quick plug for optical device that can work with these all these lenses. And then I also want to let you know that, you know, if guys are thinking about getting some lenses, we have an optical assurance program. We have sort of a lens servicing that we do. We have a very complete facility with lots of different equipment that we are known for. And in fact, we do warranty repair for several manufacturers here, and we do service work on all different sorts of lenses. So these are things that we can serve like no one else. Really, we have this a capability. I mean, there are certain lenses that either you're going to the manufacturer in another continent, or you're coming to Able Cine. Those are your only options for service repair on certain lens designs. So we kind of really know what we're doing with this stuff, and you know, we're here to, you can talk to us about whatever you have to work on. I have some demo stuff, but I think it's time to hear a little word from our sponsors. So with that in mind, we have some presentations from the different manufacturers. I'm going to take it in alphabetical order. So first up is Angenieux. And Jean-Marc, if you would like to come up while I quickly pull up your presentation. We have the hand mic for Jean-Marc. Okay. Hey, it worked.
Good. Thanks, Mitch. Thanks, everybody, to be here.
Step in the light, just so for the video.
Okay, no
feed.
problem. Oh, yeah, you have the video. No problem. Yeah, so Angenieux has been really well known for a long time for the zoom lenses. We have been starting the zoom lenses in 1956 when Pierre Angenieux really designed the first lens with mechanical compensation. So we have really a lot of experience on lightweight zoom. So in the 1960s, maybe some of you really just remember, it was really the time of, you know, when people started to shoot with handheld camera. This handheld camera has been designed here in New York or in France by Eclair for what they call the Cinema Verité. So people really can move outside of the studio, can really go in the street and really shoot something that looked more natural, more like a lifestyle. And at that time, really, the zoom became really a big thing for people because they didn't have to change the primes. If you can see on the picture on the left, in the past, the camera had, you know, a set of 2 or 3 different C-mounts. So you can put different primes, and you have to change the primes every time you change your focal length. So with a zoom, you have one lens, one mount, like all the modern camera. And so you can really get something really out of the life of the people you can shoot on the street. So Angenieux became at that time really the eyes of the world on the new film camera, which were 8mm or 16mm. In the 1990s, there was an evolution of 16 to Super 16, and also the digital HD started to become really popular. So there was a need for higher quality lenses, and Angenieux came with 2 very well-known lenses, the 7281 HR, which was a Super 16 lens, weighed around 5 pounds, and became really the handheld zoom for Super 16, and the version, the HD version, which was a 5.3 to 61. This was the first cine-style lens for HD camera, like the Cine Alta or the Panasonic VariCam. Then, in 2000, we introduced, as you know, people know the 24-290 and the 17-80 in the early 2000s, and people started to talk to us and say, well, we like the quality of the zoom because really this zoom changed the way of people were shooting. In the past, we were shooting mostly primes, and now the zoom really gives the flexibility of changing focal length all the time and really get only one lens for most of the shooting. So people were talking to us, and we started the lightweight zoom program. So what we had to achieve is optical quality. They wanted to have the optical quality as good as they had with 24-20 or the 17-80 fast aperture. At that time, there was still photographic lens that have been modified by Century Optics or other guys like Panavision. They were fast, but they had a lot of breathing. So breathing was a very important factor. And also they had the mechanical system for still photography is not as good as we have, like Mitch was saying, on the film lenses, because you need to zoom, you need to have really precise system. So this was also a challenge to achieve on that kind of lens. So the first really modern lightweight zoom, almost all of the zoom lenses you have here on that particular event are really based on that kind of first 15-40 design. This is a lens that has been very fast, T26, with no ramping, 2 feet close focus, so very close. You can really be close to the person, even if it's not something that you want in real life, but sometimes it's really good to have it. We have a very compact weight, so it's 4.2 pounds, very, very lightweight. 320 degrees focus rotation with 50 precise focus mark. So as Mitch said today, it's very important for DP who wants to have very precise focus to get all the marks at the right position. So with 50 marks, you have really the choice of the distance you want to shoot with. Compatible with Super 35 film and digital camera. So these cameras are really, the camera used for shooting a movie, shooting video right now, and available in different mounts. So PL mount is the standard. When we deliver lens, it's PL mount, but you can also switch the mount, swap the mount with Panavision. Canon EF, the Canon has been very popular now with they have 300 or 500, so you can really use a Canon EF mount on that lens, and also the Nikon F mount is available for that lens. So this is just a picture of Shameless, the show that is, I don't remember the TV, I think it's Showtime, and they are using Shameless there. Yeah. It's Brody Charter show, yeah. So we are using a 15-40 on an Alexa and really love that. So next, we had to come with a brother for that lens because 15-40 is good for handheld, Steadicam, but people really like to go to something around 70-80 millimeter for, especially for handheld. It's really the focal lens that really give really the image you want to have. So we came with a 28-76. Same mechanical package, same size package, same performance. So with almost every characteristic are the same. Really, the focal length is the main difference. So the challenge was really to put an optic that has a different focal length in the same body. So when you have a 15-40 on your camera and you want to swap to a longer focal length, you just have to remove the mount, pull the motor out, put your lens on, and put everything back together, and it takes really, just a few minutes to do that, so you don't have to reset all the gears and the accessories around the lens. So this is, I think the name, Jonathan Hall, who is shooting with a 28-76 on handheld configuration. It took us, a couple of years to really decide to go on more telephoto position. A lot of people say 76 is really good enough, but maybe you should do something above 100. And we really came with this 45-120. The challenge was really to keep the weight under 2 kilo, which is 4 pounds, and to get the quality and the performance that we already achieved with a 15-40. And with the introduction of new glass, new aspherical element, we were able to achieve that challenge 2 years ago. So we made a 45-120, so same type of range, same type of zoom mechanism and focus mechanism. So you can do like you do on the 15-40 or 28-76. You take one lens out of the camera, you put the lens back on the camera, and you get exactly the same position for all the gears. Same characteristic in terms of rotation of a focus, 320 degrees with 50 marks. But here the trade-off we had to do is only getting a 3 feet and 1 inch distance from the lens. So we can focus a little bit just far away, but the camera is still quite close to the object. So it's a really good option, and still available with Panavision mount, EF mount and F mount additional to the PL mount that comes as the standard. So here is a picture of the 45-120 in Las Vegas with I think it's with Cinelta the F3 camera. The other just thing we build around these lenses to extend the focal length is accessories. So we have a wide-angle accessories, a 0.75 time accessories. If you put it on a 15-40, you get a 11.25 millimeter wide angle, so it's super wide angle. And the extender, we build the extender really for the optimal lenses. Trust Mitch that his extender is perfect, but I think
They're lovely too.
having a lens really designed by an engineer, by an optical designer for the optimal, it's really a plus. So you, with a 2-time extender, with a 45-120, you achieve a 240 millimeter telephoto focal length. So you really get into a range of length from 11.25 to 240 millimeter. That is really incredible for lightweight configuration. Then in the late 2000, there was, I will say, the digital revolution. Red came with a camera that they can sell for kind of good amount of money, around $20,000. A lot of people were looking for good quality lenses, even if Red came with sort of okay lenses that were at a very affordable price. So we kind of thought that there was a possibility for engineers to really provide something that was very good, very affordable, and but without any compromise on the optical quality and the performance of the lens. So we designed the Optimo DP series. So the important thing was, as Mitch said, the digital camera have a really characteristic on the sensor to have, to be very directional. So the telecentricity is very important. But also you have a filter in front of the sensor. This filter is a biofilter where the red, green, and blue are not on the same position exactly. So you have to make sure your chromatic aberration are well corrected. So that was really something that we really looked to achieve on that lens. So, and of course, the breathing capability, we would like to have that, as good as the other lenses, and precise zoom and focus mechanism. So all that we put in a package. We worked with our engineers, and we came with a series of 2 lenses, the 30-80, which was the first one on the DP line. So fast aperture T28, still a 2-feet close focus, compact also, like the other one, 4.2 pounds. Same angle of rotation, 320 degrees rotation, and it's compatible with a digital camera in Super 35 format. The only trade-off, because of the mechanical system we have that available only on PL mount, so it's not available on Panavision, Canon, or Nikon mount. It's only PL mount on that lens. So this is a picture of the 30-80 on the Red camera in Venice. And the second lens we came with is a 16-42, so same range, focal range of 2.7 time. Same aperture, T28, and exactly the same characteristic as the other lightweight zoom. 2-feet close focus, compact, 4.2 pounds, and compatible with a Super 35 digital camera, PL mount only. And this is a shooting that has been done also in Las Vegas with a Able Cinetech camera, the F3.
That was also over the air in Las Vegas.
Over the air, yeah. This was an helicopter shoot. So. Yeah. Then at that time was the late 2000. There was a lot of need for 3D, and a lot of people have been using our lenses, but the 3D they really needed some adjustment, precise adjustment for making the lens perfect on each camera, on each rig. So they took one lens from one vendor, they took one lens from another rental house, they tried to match them, and they took a lot of time to do, even if it was the same range, the same type of lens, to do the perfect match. So we came what we call the 3D package. So what was important is to get the same color index, So we took lenses from the same batch. So they were really made at the same time. So you get the same chromatic aberration, the same index on the camera. So both images, the left and right, or the vertical and horizontal, were matching perfectly. So the same zoom and focus range for an easy calibration of the rig. So when we make the lens, usually we have a small shift between the zoom and focus, but due to the tolerance we have in the lens. So we had to kind of adjust that very precisely on both lenses. So if you put your lens on a rig, you get the same range on both lenses. So it's very fast for the calibration. One other thing is people put the lens vertical and people put the lens horizontal, like you have on the Atom, I think, rig from Element Technica here. So the lens has to be very precise, especially because it's vertical. We don't design the lens to be used vertical usually. So we have to really make the zoom and focus mechanism very precise on these lenses so they can really work perfectly on the vertical position. Also, we redesigned the tracking adjustment because people are using on two different cameras, and sometimes the sensor is a little bit offset on each camera. So they like to tweak the tracking on the camera. So we redesigned that to make sure that people can access that and do that easily. And the zoom range we have, so it's a 16 to 80 millimeter with two lenses. So this lens has been very popular, used on a lot of production, including the Orbit from Peter Jackson, which has been really the reference in the market. Then the last really series we introduced this year at NAB, this is the anamorphic series, lightweight series. What people are looking in anamorphic, we were looking at getting really a nice lens that can get the quality of a spherical lens in a lightweight package. Anamorphic lenses, most of them have a front anamorphic, so they are pretty big and they are pretty just bulky. So having an anamorphic group in the back of a lens was a big advantage we achieved because it just kept the weight lighter than what is available right now in the market for anamorphic. The image flatness was also very important. Anamorphic lenses have a tendency to have a very good sharpness at the center, but when you get to the edge, you get really distortion and you get also like a blurry image. So getting really a good quality from the center to the edges was very important. Fast aperture, we would like people to use the lens at full aperture. So T2.4, that's what we choose to have. It's a good aperture. It's not the best aperture, but people can shoot at T2.4 full quality. And the close focus capability is also a big trade-off with anamorphic. A lot of anamorphic lenses are really focusing 5 feet, 6 feet, 4 feet. We would like to be like below 4 feet. So that was one of the challenges we would like to achieve. So at the end, we end up with the first lens of the series, which is a 56 to 152. So this is really a lens dedicated to movement because the lens is lightweight, the lens is very fast in aperture. The image flatness and the distortion are very just perfect. So that's really a lens that really can achieve a new way of shooting anamorphic. Very compact, so 4.8 pounds, less than 5 pounds. Focus rotation of 320 degrees, like the other lightweight zoom from Engineer. Compatible with Super 55 film and digital camera, and possibility of swapping the mount between PL and Panavision. You can even put a Canon adapter, so you can use on a Canon EF mount camera. And so the last image is an image I took from a roof with my son, so with this anamorphic lens. So VN is providing a new freedom to a cinematographer. That means you really, with an anamorphic lens like the 56-152, you can really just get something new, lightweight, and you can really move into the set, not having to stay on a tripod with a lens. Thank you for listening to me, and keep in mind.
Thank you. All right, I'm going to switch over now alphabetically. We are next up with ARRI. Click out of that presentation and get to the ARRI presentation. Make sure we're at the beginning of it. And let me get you started. Sorry. Gunter.
Thank you, Mitch. Hello, everybody. My name is Gunther Nösner. I'm a technical sales rep for ARRI Inc. in New York here, responsible for primarily camera sales, but also lenses. ARRI is not a lens manufacturer, unlike everyone else here tonight. We have been, how should I say, we have been commissioning lenses for many, many years, and it started way back with super speeds, standard speeds, ultra primes, master primes. Most of them, of course, prime lenses. We worked with Zeiss primarily. Right before Alexa came out, we also commissioned zoom lenses with Fujinon. And we came out with 2 studio zoom lenses, the 18-80 on the bottom right, and the 45-250. Both 2.6 T-stop, but tonight we're talking about lightweight zooms. And a year later, we announced 2 short zooms, the 15.5-45 and the 30-80 Allura zooms. Both are at T-stop 2.8. And sometimes the question comes up, how come ARRI always puts their name on these lenses, even though they're made by Fujinon or Zeiss? And that usually works in a way where ARRI defines the concept and specification of every lens before handing over the manufacturer the duties of making these lenses. And all these things that Mitch talked about earlier, what specifications we think make the most sense. And again, we get this feedback usually from professional filmmakers that play a crucial role in the development process. And when the lens is designed, it usually goes back and forth until the final design is here. And the Allura lenses, the Allura zooms, they all have a matching color and a very pleasing look. They match ultra primes, they match master primes. Some people consider them cooler lenses, not as warm. I would say that's all relative today because all these digital cameras can be really shifted fairly easy. They are very consistent when it comes to image quality across the full range of all the Allura zooms, meaning how they perform towards the edges in the center, how the out of focus fall off is consistent. And the one difference, I think there's another Fujinon lens here that has LDS contacts, is the lightweight zooms, the 15.5-45 and 30-80, they have little contacts on the back that utilize, that basically tell the camera at what aperture, at what focal length and what zoom position they are. So this metadata is embedded in the footage, either in RAW or HD or in ProRes files, and can be instantly accessed either for monitor display, for wireless units. I have the new wireless unit WCU4 here that also takes this lens metadata and shows it instantly to the focus puller. Now, a little bit more about these 2 little lightweight zooms here. They're optimized for digital and analog cameras. We also offer them for 3D productions in matched pairs. And one second, this does not work. Okay.
2 fingers full.
No. Oh, here it goes. Okay, I did it backwards. Now it works. So they are high-resolution lenses. They're designed for 2K or 4K plus cameras. Very high contrast and minimized flares and veiling glare. They have Fujinon multi-layer electronic beam coating. and a large image circle, projected image circle of 31.5 millimeters. That means it will cover almost every digital camera that is out there today. They have very low geometric distortions and even field illumination. 9 iris leaves for round out of focus bokehs. A very consistent contrast, and they are very robust. I mean, I have some lenses here. The front diameter of the lenses are 114, so it matches master primes. And there is the option to actually change. You can replace the focus scale if you want to have meters or feet. They have a sophisticated zoom centering mechanism, so they track perfectly. And again, the reason we commissioned Fujinon was because we wanted to come in at a price point that was, at the time, more competitive. I know Angenieux is very popular when it comes to zoom, but we wanted to end up in the $26,000, $27,000 range. So this is what each of these lightweight zooms cost. Now, I know, Mitch, you said that you have the world best extender. I don't think so. Because we developed also extenders that are basically working beautifully for Allura, for all the Allura zooms. And not only are they optimized for Allura zoom, they also work with ultra primes, they work with master primes. And I had a first look at them at NAB. There's a 1.4 and a 2x extender. The 1.4 has about a 1-stop loss, and the 2x extender has 2 stops. And this allows you basically to get much more range out of your lenses. You can see if you have all 4 Alluras, you can start from 15.5 all the way to 500 millimeters with 4 lenses. And this is actually the end of my short little presentation.
I think we're going to have to do another expo one day for extenders only. So many choices now. Thank you, Ari. So next up, we have, in alphabetical order, Canon. So, Mr. Thorpe. Here we go. Pull up your presentation. Yeah, do you want to? Yeah. Do you want to? You go to the presentation first?
Yeah.
Okay. So
Thank you.
Thank you.
Thank you. Good evening, all. 10 minutes. We're going to go through this fairly rapidly. Our lenses for the cinema were born of a project that was about 5 or 6 years ago when we were asked to develop an 8K lens to support the UHD TV developments of NHK. This is 16 times the resolution of HD TV. So we had to go back to fundamental physics and optics. This is the lens. I draw your attention to the fact that it is actually a rather small format dictated by NHK, and we had to get that sort of resolution into that very small output image. So we went back to basics, and from that was born a new optical platform on which we based all of the lenses that I'll describe tonight. Now, when you talk about an optical platform, you're using most contemporary in new softwares and computer simulation tools, hugely important in lenses of this genre. And then you go to the materials themselves, new glasses, new multi-layer optical coatings, and very advanced optomechanics. And then last but not least, the assembly, the manufacturing, because when you're talking about 4K and above, precision of mounting those elements and holding that precision with large ranges of temperature excursions in the real world. So very rapidly, just to position the two lenses, we're taking into account the two variants on Super 35, the television-centric and the cinema-centric, both standardized by SMPTE. And the dimensions of our Super 35 are one of those tiny variants that Mitch described, everybody slightly different, and these are our numbers here. You'll see the verticals are the same, the horizontal, this one's slightly wider aspect ratio. Now, we started with, 2 years ago, with two what we call top end. These are two 4K lenses available in PL or EF mount, being the best we know how to make within a certain price limitation. They're not cheap, but they are the base, and they're based on that platform that I talk about. The best we know how to make. We call them over 4K. I'll elaborate on that in a moment. Now this, we designed at that time with a 29.6 image circle, which does encompass all of the contemporary Super 35 except the Epic, which came out the same year as this lens, and wouldn't you know it, they decided to go with a bigger image format. But we did announce that year we would follow with two of the compact lightweight lenses we talk about tonight, and those do have, they are here, and you can see this is the relative size, the actual relative size there. And they do have the larger image circle, so these lenses will encompass the Epic. We followed them with prime lenses. Won't talk about those tonight. We're going to focus on these. I just wanted to position them for you. They also are available in PL or EF mount. So looking a little more closely, this is the 15.5 to 47 millimeter, and identical size, though the picture jumped a little bit there, identical size, identical positioning of the rings, the gearing, are the 30 to 105. Both of them T28. These are the two lenses here, relative and focal range. This guy, of course, goes off the chart out to 300 millimeters, but just to show you the stacking of the focal ranges that we made available. Now, here's the operational specs. I'm not going to make you dizzy with them. I just draw your attention. Both of them are T28 across the entire focal range. They both have 11 blade iris. This one has a very sweet 80-degree wide angle in the 1.9 cinematography aspect ratio, and the 4.8 pounds for each of them at the bottom there. Now, a little bit about performance. We went all out in the design of these. When I talk about that new optical platform, we went all out for the highest contrast ratio possible. And that is your new glass materials, and most important, the new exotic materials we use for multi-layer optical coating. Because if you start with a high contrast ratio, now you can hold your resolution, MTF, which is the modulation of the transfer of that contrast as you raise the spatial frequencies. That's what sharpness is all about. And then excellent color reproduction. Now you want to control the aberrations because, as was pointed out Mitch earlier, they can chew away at your resolution. You've got to minimize the many optical aberrations that there are and geometric distortion. And then last but not least, sacred to the DP, the cinematographer, minimize the vignetting, minimize the focus breathing, and management of stray rays or very strong light sources. And I'll give you a demonstration of that a little later. Now, a little bit about 4K. This is the dimensions of the images I talked about. These are the numbers in the digital domain of what 4K is, 4,000 by 2,000. So a very simple calculation says that if you take that, we can resolve half of that. That's what Nyquist is all about. Divide that by the 13.8, and it says a 4K lens has to deliver 80 line pairs in every millimeter. Now that is 80. You can count them if you want. I carefully drew 80 line pairs. You got to pump that through every millimeter of these lenses with a very high contrast. That's the name of the game. Keep that contrast very high. So you're talking about image sensors, you're talking about the lens, and if this is the Nyquist, this is it in the electrical terms or the optical terms, you'd like that to be as high as possible. But it's a little more complicated than that. And by the way, when you look at the passband of a 4K, HD or 2K is roughly half of that. So if you do have a very good 4K lens, you are going to have a spectacular HD lens if you hang that on an HD camera. This is very, very important. But as has been reported by more than one of the optical manufacturers, and we are one, over the years, in terms of subjective testing in the cinematography world, it isn't so much what you've got out here or beyond here. It's what is your resolution in the center there. That's the sweet spot here. Why? Because it's in there that your picture edge sharpness and your textures are defined, not out here. So the whole name of the game, and by the way, this is the human visual system. We have a little MTF ourselves. What we actually perceive when we look at images is what's inside these two curves. So if you're looking at a wide-angle shot of the New York landscape, or all the buildings, those are edges, going to be largely determined by how high this curve is. You're looking at close-ups of faces, hair, facial detail, textures on clothing, very largely determined here. So getting this MTF as high as possible is the name of the game, making a terrific 4K lens. Now, when I talked earlier about those high-end lenses being over the top end, as we call them, and the compact lenses that I'm describing tonight, these are not the actual curves. This is just conceptual to show what we mean by over 4K, what we mean by 4K. Both of them have very high MTF in that sweet spot that I described. This is very important. Now, if you're going to have lenses like this, the two I'm describing, with modest zoom ranges, if you can get the performance high enough, they can become your variable prime. Rather than changing a set of prime lenses, you just vary the prime by changing the zoom. But that places very high performance expectations. Your resolution, as Mitch pointed out, always sweetest at the center. And all lenses, as you move away from the center, that resolution will drop. The strategy is, though, can you keep it as high as possible in the most important zone of the image? And our numbers in millimeters, these are our Canon numbers. The other optical manufacturers have their zones, but these are our zones. We call it the inner, and then an outer field, and then the extremities. So our strategy in designing this was to try and hold the resolution as high as possible in here. Every strategic design we can do, we implemented, and then it has to relax out here to some degree. Now let me calibrate you. This is a 2/3 inch lens, one of our top-end 2/3 inch portable lenses, HD. I'm not identifying it because we're not allowed to publish our numbers. I'm not giving you any actual numbers, but these curves are the real performance of that 2/3 inch lens. And what it's showing you is how the resolution holds up in that inner square, which is here, what happens in that outer region, and then in the fringes out here. Now you can see it's very, very good. And by the way, in addition, I'm showing you the way that resolution varies over the focal range of the lens. So you're looking at two variables here, center to extremities, and what happens to center to extremities as you change the focal range. Our new 4K lens, the compact lens there, that's the actual performance of one of them that I have not identified, the resolution at that sweet 40 line pairs per millimeter. Look how tight that is. Look how flat that is. Yes, now it does roll off out here. All lenses wear. So we have achieved what we believe is a variable prime that will match any set of very high resolution primes. And that was the name of the game. In addition, they both hold that T28 over the entire focal range. That's very important if you want to be a variable prime. Optomechanics, very, very important. Optomechanics determine three things. One, the stability and reliability and integrity of the mounting of multiple elements and holding that as you go from the Arctic to the desert. Because remember, the coefficient of expansion of metals is different to glasses. There could be 15 different glass types inside this lens, and there are mounting strategies using special materials that compensate for that difference in temperature coefficient. That's part of the science of optomechanics. The other big part of optomechanics is, of course, for the cinematographer, the all-important precision and repeatability of your operational adjustments. We have a 300-degree rotation on the focus of these lenses, and we have 160-degree on the zoom. And last but not least, the optomechanics is also a major contributor to the control of the ghosts and reflections that you get from fierce light sources going directly into the lenses or the sun coming in off axis and bouncing around. So there's a lot of things done inside the optomechanics that is part of the science of optomechanics. Now I'm going to show you a little video that was shot a little recently using these lenses. We used all 4 of our zoom lenses for this little video, but the 2 top end were used for some of the staging shots. Most of the action that you'll see were both of these compact zoom lenses that we have here tonight. Stephen Poster, some of you might remember him, might recognize him, a very well-known DP. And the second was mounted on a Steadicam. It is a little dance troupe, and we're going to show you this right now. I'd like to draw your attention to the fact that we deliberately asked the DPs to torture these lenses. We said, we want to show folks how we hold up the contrast, the sharpness, and the dynamic range, that very high contrast ratio, and pay particular attention towards the end when we shine some very fierce lights directly. You see these lights, switching lights around on the dancing troupe directly into the lens. Watch the way we hold up the contrast and the control of the aberrations. And with that, I'd ask you if you'd run that little video. It's 3 minutes, and then we're over.
Oh, I think I'm at the end of it.
You're at the end, yeah.
Let's redo that real quick. I can grab the, there we go.
Would you turn the lights down a bit, possibly?
Is it playing? There we go.
All our lives are based on rhythms, our bodies, minds, and our feelings. I grew up in a big city like this, alive with rhythms.
Shoulders to shoulders, and for love we are peaceful warriors. To see ourselves in each other. Oh, there's nothing stronger, sister. Brother, we don't need to love, we don't need to hide. Everywhere we are side by side. We all need to carry the world on our shoulders. We don't need to worry. Bring our hands together. We don't need to run. We don't need to hide. Everywhere we are side by side. We don't need to run.
Tap dance is pure rhythm and movement as one. It takes passion, dedication, and hard work, but it's so much fun.
We're rolling together. We're rolling together. We're rolling together. We're rolling together.
4K, and you watched the down conversion to high definition on the screen here tonight. When you see it in 4K with a cinema projector, the dynamic range is quite extraordinary. Everybody's commented on that. Thank you for your attention.
Thank you, Larry. I'll just pull that out. And we go to, oops, it's going again. Go away. We go now to Fuji. Tom, would you care to come join us? Let me get your presentation lined up. There we go. Oops, I'm not in the beginning. Oops.
I'm done.
Ignore that man behind the screen and what he was just doing there. Oop, oop, let's get you to the right at the beginning. There we go. Here you are, sir.
Thank you very much.
Yeah.
My name is Tom Calabro. I'm Director of Marketing and Product Development for Fujinon. And first of all, let me be very clear. I like Able Cine and Airy extenders equally. And Mitch, thank you very much for that lens primer. That was fantastic. That was a lot of good information in that. We've been making lenses a long, long time. And this year we're celebrating our 40th year in North America. I know we're talking about lightweight zooms here, but I just want to mention our Premier series, the 4K Plus lenses. These are lenses that go from 14.5 all the way up to 400 millimeters. Very fast, as you can see, the T2, T2.6 is 24 to 180. And the 75 to 400 is T2.8, and then it goes down to a 3.8. These are the ultimate in high performance for zoom lenses. I have a brochure outside. It's a reprint from Film and Digital Times. It was an interview with Claudio Miranda done by John Fowler. And Claudio used some of these for The Life of Pi, which he received the Academy Award for. But quite recently, he used 2 sets of these for all the exterior shots for Oblivion. So if you get a chance to see that, again, all these are being utilized in that production. The one thing that really caught my eye when I was reading the interview was that Claudio said that these lenses were, as for zoom lenses, they were sharp or sharper than his prime lenses. So that there is just quite a statement. But not only are they sharp, it's the lenses have a uniformity to them, as Mitch was talking about earlier. It's a uniformity in light from center to edge, a uniformity of resolution from center to edge. Another hallmark of Fujinon lenses is the contrast. You take the lens and you produce your image, and it has that richness to it, and that has to do with the coatings. It has to do with the construction inside the barrel itself, the materials that we use to coat inside the barrel. So there's a lot that goes into actually all of these lenses. These are very, very complex devices. One of our ENG lenses, one of our bigger ones, and all of these lenses, they're really handmade devices, and that's one of the reasons why they all cost so much. Once all the material is made and produced, the barrels, the glass is all coated and polished and everything. It'll take our engineer over 40 hours to put together that lens and to align it, to make adjustments, and before it goes out the door. So a lot of man hours, and that's where a lot of the money comes into these lenses. Now these 4K lenses, they were developed from our 2/3 inch Super Cine E-Series. The most important thing is that they use a low dispersion glass. They have a very high refractive index glass. They have very complex and precise zoom mechanisms, so they will hold the focus from end to end, that the centering stays where it should. The new EBC coatings, again, all these lenses have very complex coatings, and that's what gives us our rich contrast performance and helps our superb resolution. These lenses have 3 moving zoom groups, and this is what allows our lens to stay in proper resolution or proper focus from center to the edge all the way through the range. So the chromatic aberrations are very strictly controlled, and that's what made these lenses very, very high quality. And the reason I'm bringing all this up is because all of this technology is in our Cabrio, our lightweight zoom lenses. We also developed a new high transmittance EBC coating, and basically it will give you better transmittance of the blue and the green light. It will give you a much flatter range and a higher range, so you're getting more light through the lens. Actually, I thought I had another graph up there. So all of this goes into making our lenses. Now, what makes these lenses quite unique is that, as you can see here, is that it has a motor drive built in. Those of you who are familiar with broadcast style lenses, this would look very, very familiar. But what this motor drive will do, it'll allow you to connect wireless or wired controls, any cine style. It does have a macro feature, so you can get extremely, extremely close focus on small objects. It has 0.8 cine gearing. Not to disappoint Mitch, I do have a 9-blade iris in here. And what Mitch said was very important. It doesn't, the 9 or the number of blades doesn't really tell you the whole story. It's not the whole picture of what bokeh is. We have other lenses that have 11-blade iris, yet you can look and you can see the difference, and in some respects you would like the bokeh better in this lens than the higher blade, number blade iris. The barrel markings are luminous for working in dimly lit or dark situations. We have 16-bit encoders built into the lens for extremely accurate metadata information. We have LDS and iTech lens data, and we have a hot shoe built into the lens for those cameras that do have hot shoe, so you can have the metadata, you can have the power, all going through without the need of wires. And of course, if you have a camera that does not have that hot shoe, we have ports on the bottom of the motor for external type control. And of course, you can take the motor off and run this just like a regular cine lens. Any of the standard cine type controllers will mount right on this because of the 0.8 gearing. As I said, very high optical performance. Our lenses are designed with the latest optical simulation technology. As Mitch said, there's a lot of numbers involved when you design a lens. You pick a set of values that you'd like to see. The size of the lens, the focal length, the weight of the lens. And you come up with a basic set of numbers, and then you start designing. Well, it turns out that when you do something at this side of the lens, well, you affect things way down the line that you may not realize and may not see for some long period of time, and you could put yourself into some problems when you're doing this design. Well, we designed our software called, what is it called, Mitch?
I don't know. Your software.
It is our software, and I'll think of it in a second. But we designed the software so that you can, that the engineers could design the lens, and it will keep track of all of these numbers. And so we could bring lenses to market much, much faster than we believe anybody else can. It also allows us to design the lens much smaller and lightweight. To give you an example, we have an 88 by 8.8 times lens for the broadcast market. Well, we just brought out a 99 by 7.4. Much bigger lens, wider lens. Turns out it's more compact. The 99 is more compact than the 88 because of our optical simulation technology. As I said, the lens is very flexible. It does have the servo drive on the side, so it's great for handheld run and gun type or rear controls. And again, it can be run with the servo on or with the servo off, with standard rods, mat box, et cetera, et cetera. The lens, give you some of the specifications. The first lens that we brought out in the Cabrio line is the 19 to 90. It is flat T2.9. It does have the 9 blades. The focus rotation is 200. Now that's a little bit less than some of the other lenses that you've seen here. I think Canon had a 300 area, I believe it was, or Angenieux had a 320 degree rotation. That is a little bit of a problem if you're going to run in a ENG style situation, a run and gun. If you look at a standard ENG broadcast lens, the focus rotation there is more like 180 degrees, 190 degrees rotation, because your hand is on the focus and you just run it end to end. 300, 320, you'd be sitting there and moving it. You'd have to take your hand off and put it back on in order to move it. So that's one of the reasons why we have 200. It's more than our broadcast, but it's less than our cine. Our big cine lenses are about 280 degree rotation. Does have the macro, mentioned the gear pitch of 0.8, 16-bit resolution, lens data. Something quite unique here is their back focus. Most of the cine lenses that you see that you would get from Able Cine if you're going to rent, they will have to take the lens and they will shim the lens to match up to the camera. We don't have to do that. We have a built-in back focus mechanism. We're very, very competent in doing this because we've been doing it for years in our broadcast lens. So it is an adjustment that's built in and it will hold true. So there's no need to worry about that. The weight of the lens is 2.7 kilograms. That's with the servo. Without the, it's a 0.5 less without. And we cover the sensor size of 31.5, actually a little bit more, but we guarantee that we'll cover the 31.5 millimeter. We just introduced the 85 to 300. Again, all the same features. It weighs a little bit more, 3 kilograms instead of the 2.7. Of course, it is the PL mount. Zoom range of 3.5. It is flat from 85 to 218 millimeters, and then we drop off to T4 at 300 millimeters. And we have announced that we're going to have a wide-angle lens that will be available for later this year, again, in the Cabrio line, and all the same features and functionality are the same for all the Cabrios. On this, the weight has not been determined, but it's probably going to be close to the other two. And we expect it to be T2.9. So we're going to be covering with the Cabrio series from 14 millimeters all the way out to 300 millimeters. And just to give you a little view here, in the top you can see the connector that's sitting on the side of the lens. That's usually covered if the motor drive is off, and of course if the motor drive is on, the pins of the motor drive are connecting with that. In the lower left is the back of the drive as removed. On the bottom of the servo, as you can see in the bottom image there's a couple of connectors for using standard Fujinon rear controls. There's the switches for having the motors engaged or not engaged, so that's servo or manual. And there's a 20-pin connector there that will go to a variety of other devices, such as a P-tap or for power, also for data, for wireless controls can plug into here, and et cetera. And all the way on the right, you'll see the rear of the lens with the 2 sets of small little connections for going to a camera hot shoe mount. So these cabrios, as I said, they're quite unique, and the best thing about them is even though it looks in one mode like a broadcast ENG lens, in another it looks just like a standard cine-style lens, it doesn't ask either camp, whether you're in the video camp or in the cine camp, to compromise. It gives you all the features and flexibility, whether you want to go handheld run and gun or you want to go with a complete cine setup, you can do so. And so again, quite unique, and we're happy that Able is here to supply them for you. So thank you very much. Appreciate your coming out tonight, and have a good evening.
Thank you. Well, and then last but certainly not least is Zeiss. Let me pull up the Zeiss presentation. Here we go. Come on. Rich, come on up. There we are.
There we go. Here you are, sir.
Thanks, Mitch, and thanks everyone at Able for the invitation. I'm going to keep this short and sweet. I'm going to give you, I'm Richard Schluning. I'm the National Sales Manager for Carl Zeiss in the Americas. I'm not a technical person, so I'm going to keep this more of a product overview than anything else, and try to give you some background about the thinking behind the compact zooms and why we brought this new line out. Zeiss is mostly known as a company that makes prime lenses. We've had a few zooms in our past, but mostly we concentrate on making primes. But we've opted to make.
Maybe you just hit the space bar.
That's weird. What's it doing all the way down there?
I don't know.
That is really strange. Can we restart this maybe?
Sure.
Thanks. Hang on. Let me go back. I'm missing this whole...
Something not coming up on the screen?
Yeah, this whole center part here.
Okay, well, we'll reload it.
Yeah. It's...
Okay, excuse me.
Sorry. Technical timeout.
Ignore me. I'm just going to close it and reopen it. It's in here. Where are we? Lightweight zooms, presentations. This is yours, right?
Yeah.
Let's see what happens this time. Spacebar each time.
All right.
It comes up.
Here we go.
That's one line more.
So a couple years ago when we started the development of the compact zooms, we made some pretty broad assumptions of what was happening in the marketplace. First assumption is that camera technology is changing pretty quickly, especially over the last couple of years, and we think this is going to continue to change as time goes on. We also know that the resolution of these cameras is increasing, and that's really due to two very different reasons. Pixel sizes are decreasing, so the amount of photo sites that are packed into a physical sensor is going up, and we also know that the size of sensors is also increasing. These are two what can be very independent differences, but this is what's really leading to the increases in resolution in cinema cameras. We also know that some zoom lenses made for still photography are not necessarily well suited for motion capture, that there is some focus shift through the zoom range. We also know that the focus control is fairly limited, so the angle of focus rotation from close to focus to infinity is rather short, and as the sensors get bigger and depth of field gets a little shallower, focus control is really where it's all at. So the design goals behind the new compact zoom is to be able to not only resolve the fine detail that smaller photo sites give us, but also to be able to cover the image circle of a 24 by 36 sensor size. We connect the dots in the changes in technology that have happened over the last couple of years. We think it's only a matter of time before we start to see big chips like this in digital cinema cameras. We start to see it already. We think over the next couple of years that this is going to be de facto. We don't necessarily think that the market is asking for this, but we think that the camera market is so hyper-competitive right now that a manufacturer is going to step up and do it just to differentiate themselves over the other. So what we really wanted with this new lens is to make sure that we had a companion zoom to the ARRI Zeiss Master Prime and Ultra Prime lenses in terms of its image characteristics. But we wanted to make sure that the price point matched our compact primes as an entry-level price. So we set a very high image quality goal, but also a very attractive price point. And we wanted to make sure that the lenses were as future-proof as possible. And so these lenses are compatible with the interchangeable mount system that we have in our compact prime system. The first lens we announced was last year at the NAB 2012 show. It's a 70-200. It's unique. It's the only cine zoom in the world that covers a 24x36 chip. Its image diagonal is 43.3 millimeters. So we think it's going to be basically covering the biggest sensor that we envision seeing in the marketplace right now. It has a choice of 5 interchangeable mounts, from PL to EF to F mount, micro four thirds, as well as E mount. This is user interchangeable. It takes about 5 minutes to swap a mount out. This is being done every day on the compact prime lenses, and the procedure is identical with the compact zooms. There was no focus shift over the zoom range, so it's a true cine-style zoom. Very robust cine-style housing. Consistent aperture over the zoom range, so there's no aperture ramping. We use an 18-blade iris in this particular one, so basically it really doesn't, bokeh is a very subjective look, but basically the idea here is to make sure that your out-of-focus highlights take on a very round and organic look. It doesn't take on the shape of your aperture blades. Great flare suppression through the Zeiss T-Star anti-reflective coating. It's the same anti-reflective coating we use in our Ultra Primes. Calibrated focus skills, obviously, and 4K ready. And by this I mean 4K ready not just in terms of being able to resolve the fine detail of these small photo sites, but also making sure that we cover the big image circle size that these chips are giving us. We look at the trend, particularly with the new Red Dragon sensor. They're achieving 6K through a combination of both some smaller photo sites, but also it's a physically bigger chip. That's 6K, it's a 34.5 millimeter image diagonal. There's a lot of legacy lenses, PL mount lenses, that are just not going to cover that sensor size at 6K. This lens will without any problems. The second lens was announced at IBC last September. It's the 28-80. It's the second lens as part of this family. So again, covering full 24x36 chip size. Same interchangeable mount system. Again, the same design parameters, making sure that there's no focus shift over the zoom range. Again, the same robust cine-style housing. In fact, a lot of the specifications on this lens are identical with the 70-200, with the exception it uses an 11-blade iris in this case. So we had some physical limitations in terms of the number of blades we can put into this lens. Instead of 18, it was 11 blades. Again, no aperture ramping over the zoom range, uses the same T-Star anti-reflective coating, calibrated focus scales, and also 4K ready. A little bit of sample footage. I'm going to show you a couple clips. The first one is really to show the fact that there is no shift in focus over the zoom range. This is a little 30-second. Nothing too fancy, just basically showing you that, again, one of the design requirements here, just making sure that there's no focus shift over the zoom range. The next clip I actually got this morning. This was done by a German filmmaker, Tom Foreman. He's doing a little film project on the Bavarian Radio Symphony Orchestra in Germany. He's using both the 28-80 and the 70-200. He's shooting on a 5D Mark III. And this is a little 3-minute clip. Oh,
Hang on.
Oh, it didn't do it. We can pull it up directly if you need to.
There we go.
Oh, there we go.
So his main goal was to have something small that's light, unobtrusive. He's working in obviously a symphony environment. So a little bit on pricing and availability. The 70 to 200 is now shipping. It started shipping in February. We've targeted a list price of $19,900. Trying to keep this affordable for the owner-operator, someone who's got camera, wants to bundle lenses with it. Lead time for new orders is running currently about 7 months. We're doing our best to bring this down right now. The 28 to 80 shares the same list price. Actually, I made a mistake here. Actually, deliveries begin in July, not February 2013. Lead time on this one is running right now about 8 months from the time of order. And the interchangeable lens mounts, again, these mounts can be changed at any time in the future. The list price on these mounts are $390 each. They're available in choice of 5 mount options. The mounts for the 70 to 200 are currently in stock. 28 to 80 will start shipping when that lens starts shipping in July. I will mention that there is a third lens in the lineup, and the first thing I'll mention is that this lens actually has been discontinued. So we've announced the end of life on this product. We announced that actually last year at the IBC show. Our intention is to replace this lens next year with the third compact zoom lens. So it will take its place as the short zoom in this lineup. We've opted to replace this lens not because of anything that's wrong with it. It comes from our Master Prime family. It's very lightweight, excellent image quality, but it covers Super 35 only. And we really think that the future, particularly if you're talking about investing in lenses that are $20,000 and plus, is you want to make sure that your lenses are as future-proof as possible and that you can use these lenses on cameras, not just the cameras that exist today, but the cameras that are going to exist 2, 3, 4, 5 years from now. So again, we've opted that we would focus our attention on a replacement for this lens. But a couple points I will bring out. And the idea with the short zoom that will replace this, again, is along the same lines. It'll be a small, lightweight lens. Again, no focus shift over the zoom range, with interchangeable lens mounts, extremely high optical performance. Again, this one came from our Master Prime family, so it used our bit more advanced anti-reflective coating, the T-Star XP. Just a really lovely lens. I've got probably another 3 or 4 left in inventory, and after that, that's all she wrote. So that'll be effectively the end of life on this one. And again, just an example of the lens on camera, showing how versatile, anything from an entry-level DSLR to a high-end to DSLR. And I'm not going to show you this footage, but a couple things I will point out on the chart here. The minimum focus on the 28 to 80 is 2 feet 8 inches. The lens weighs 5.5 pounds. On the 70-200, the minimum focus is 5 feet, and this lens is 6.2 pounds. So it's a little heavier than some of the other lenses out there for Super 35, but again, you have to keep in mind that it covers a much bigger image circle size and there's a lot more glass inside. And real quick, I'll just go over a couple slides that show you how easy it is to swap out these mounts. The diagram here is on our compact primes, but the procedure is identical with the compact zooms. It's not a mount adapter, it's actually you're physically exchanging the mounts. So you're backing out, in this case, this is an EF mount. You're backing out 4 Torx screws, which is the EF mount itself. There is a spacer ring that's held on with 8 Torx screws. There's a set of shims underneath it. And that combination then, you can then replace it with PL, with a Nikon mount, with an E mount for Sony, or a Micro Four Third mount. Process, again, is very straightforward. And it's just tightening down the torque wrench. I'll point out that the rental houses are doing this every day, day in and day out. And with that, that's all I have. Thank you.
Thank you very much, Richard. So I want to ask for your indulgence for a little bit longer. I want to give everyone a chance to go back out and take a look at what these different lenses can do for you. But I want to sort of take a brief moment to demonstrate a little bit what these lenses can do for you. So Naomi, if you would come up. Naomi is our lovely model who has been patiently waiting all day for us to actually point a camera and give you an image. So if we can get the picture up over here, Jeff. And I just have an Alexa that Ari was nice enough to bring over. And I haven't even framed anything up or anything. We have Naomi here. This is the lens that was on it. I asked each of the manufacturers just to bring over some of their lenses. All of these can cover something in around these are all the sort of the mid-range zooms. So this one on here is the Alexa Allura 30-80. I'm going to just get a quick focus. Just by eye, that's about right. And put it at 50 millimeter. And then Jeff, if you can turn on the lights in the back. I'm just going to scoot over here a little bit. I just got some rope light there. And I did it just so that we can have some highlights in the background and see what it might look like. And I think I'm right near a speaker, so I'm getting a little bit of echoey effect there. But that's what this lens will give you in highlights. I think exposure-wise, I'm just going to make sure all these lenses open up to about a 2.8. It's hard to tell in the room, getting a lot of bounce around of light, but that's a pretty healthy exposure on the image. And this is where you can start getting a sense of the different characterizations of the lenses. So I'm just going to show you a couple different lenses. You guys can tell me what you want to see. I'm just going to quickly knock it in and out of focus, and you can see what happens to the image. You can look at those little highlights in the background, and the whole thing's shaking as I do it, of course, but you can quickly just get a sense of what happens as out of focus highlights. If I stop down, oops, wrong ring. If I stop down the lens, you can see what happens to those little circles. And it's also important to look at the geometry of the lens, what that kind of does to her as you knock it in and out of focus, and what the edges of the skin and stuff like that. So I can just show you a couple different lenses. I want you guys to have a chance to look at things. Don't want to go like crazy long tonight. Any particular lens anyone like to see next? Don't have the anamorphic over here. I think that's going to get but I don't have. I'm not going to show an anamorphic because we don't have an anamorphic thing for this camera, and I'm not. So I think that would take a little bit of time to reset for that. I think that why don't we first right now just look at these circular lenses. If you want to see the anamorphic lens, Angenieux does have it set up on their camera out there, but. Any particular one of any manufacturer's lenses anyone wants to see? You can call it out. Okay, we'll grab the Angenieux. Here's the 45 to 120. So I'll put this on here real fast. We'll just take a couple minutes to do this. Oops, and I'll just grab a quick focus. And again, I'm zoomed way in, just so I can grab a quick focus, and we'll be at about 50 millimeters, which is where we were before. And it has a little bit of a different look. The color is a little bit different, and the geometry of the image. And this is just, again, at 50 millimeters. And as I knock it in and out of focus, you'll see that the lens has a little bit of a different look. Again, they're both a 50 millimeter, and these are subtle differences, but they do have a little bit of a different feel. All right, so we've looked at Arri, Allura, and we looked at Angenieux. We'll quickly go to Canon. Here's the 30-105 from Canon. Back to my AC days of how quickly can I change out a lens without mucking it up. As long as I don't drop it, it's a good thing. That looks pretty sharp. All these lenses get very sharp. So there we are at about a 50 millimeter. Again, similar size frame. It has the warmth, the relative color reproduction. It's a little bit different. I see it in her hair and her skin tone. The skin tone is the thing that always stands out the most to my eye. And when I knock it in and out of focus, again, you have a little bit of a different quality to it, and that lens can get very, very close focus, so you can really knocks it way out of focus. But you have a different sort of feeling to the geometry of the frame and the way it sort of shapes her head when I not roll it in and out of focus. Not better, not worse, just different. Right? Anything else? You guys tell me if there's something you want to see when I do it. Okay. I wedged it on there. On to Fuji. World's fastest lens changes. Okay, here is the Cabrio 19-90. Oops, I'm going to have to swing these motors way out of the way because we have the hand grip on here. Am I still bumping? I'm still bumping. Let's just swing the motors out of the way really far. There we go. I think I'll clear. Do I make it?
Yeah.
I think I'm missing. Hang on a second, guys. There we go. Okay. Oh, but I gotta turn off automatic aperture stuff. And then we'll bring it out to 50 millimeters. So again, similar size, different kind of color in my eye, just a little bit different, you know. And when I swing it in and out of focus, I see it affecting the image in a different way. It's all about, you know, do you like vanilla? Do you like chocolate? Do you like sarsaparilla? And lastly, we'll go to the Zeiss. This is the Zeiss 28-80. Thank you. That aperture. And here we are at 50 again. A little bit less red in the color. Again, it's very, very slight differences, but that's a slightly different kind of color to a Zeiss lens. And then here I am knocking in and out of focus, a very different effect of focus from the last couple lenses that we saw. And I mean, it just sort of just drifts its way in and out without the geometry particularly changing. Again, not that that's necessarily better. For one guy, it's better. For another person, it's worse. I guess it's whatever you like in the style of the lens. I just wanted to give you that real quick, just to get a sense of how, even though they're the same, they're different. Yes.
Can you stop it down just to hear?
Sure. Stop this down the lens just a little bit. I went from a 2.9 to a little over a 4. And I'll go in and out of focus for you if that helps. There's a slight difference there. Sure. So I just wanted you to see that the lenses do each have their own personalities, their own styles. They're all excellent lenses, but everyone has their own design parameters and design characteristics, and what each manufacturer really feels is a little more important this way and a little more important that way, and it's based really off of feedback from users. What are the things that you like to see out of a lens? And that's why, Able Cine is happy to represent all of these choices for you, because hopefully we have something that you would like to see. I'd like to invite everyone to go outside to look at what all the manufacturers have to offer. Naomi, if you wouldn't mind, you'll sit out on the stage. And before we go out, and so you can take a look with the different cameras and see what different lenses can do. Before we go out, I want to thank you all for coming. And I also want to mention that coming next month in June, we will have our next Able Cine Expo. It's going to be a bi-coastal, meaning that we're going to do it on June 22nd here in New York and then June 29th in Los Angeles. It's alternative camera movement. So different ways and different systems that you can use to move a camera around, not just on a big heavy dolly or on a big crane. Lots of different fun toys we'll be showing there. Thank you again all for coming. Appreciate everyone who's tuned in on the internet, and see you again soon. Yeah, I guess we can take all these things out. It's like, how can I do that really, really fast?
Very well.
Thank you. Sure, thank you. And then I'm just going to shut you down so that you can